All right. My name is Eric Bichard, and I am the developer advocate at Couchbase for NodeJS. And today we are going to be talking about JSON data modeling for the document database world. So on the agenda today, we'll talk about why you would choose a NoSQL database, basic JSON data modeling, things you need to know to get started in a document database, particular to Couchbase. We'll brush up a little bit on relational versus document schema, some of the other types of NoSQL databases out there, just to give you a nice understanding of the landscape. And then finally, we'll get into JSON data modeling and document database relationships. So let's go ahead and get started. So the first question is, why NoSQL? So when someone chooses a NoSQL database over a relational database, it's typically to deal with situations like scalability, flexibility, and availability. So we'll talk a little bit about what each of these means in a document database. So as far as scalability, with databases like Couchbase, you have the ability to scale, and that is key. Clusters are made up of many nodes that can easily be increased or decreased based on demand. So imagine that your system needs more demand for an event like a Black Friday event, right? Before Black Friday, you may not have as much traffic. When Black Friday hits, you need to kind of scale up, make sure that you have available nodes, failovers, and all that kind of stuff to be able to serve your customers for a situation like that. And then afterwards, you might need to scale back down. Now, more nodes can be added and the cluster can be configured or make changes itself to auto-distribute things like CPU, RAM, disk space, etc. When it's needed. And then again, like I said, scale back when it's not. Another thing that we talk about with scalability is kind of one-dimensional versus multi-dimensional scaling and the benefits one can get from this type of scaling. This is not something you generally need to worry a whole lot about on the developer side, but as a database administrator, understanding the two and kind of how they differ is very important. The minimum nodes for a Couchbase production for deployment is 3. But like I said, you can scale up or down. In the case of like a Black Friday event, you might need to go up from 3 nodes to 4, 5, 6, 9, 12, whatever, to be able to help take care of that demand. You can only go up to 1,024. I don't think any of our clients have ever gone that high. Scaling up these nodes will cause a rebalancing and distribution. And with a platform like Azure, you can actually use almost like a slider bar to be able to scale up your nodes in your cluster. And of course, you have the ability to scale back down whenever you need to when the load is not there. When we're talking about one-dimensional versus multi-dimensional scaling and kind of how these nodes, these extra nodes get added, you can do it in 2 different ways. So one-dimensional scaling, think about if you had 3 nodes in your cluster, okay? And each node takes care of all of the services, query, index, and data. So as you scale up, right, as you go from 3 to 4 to 6 to 12 nodes, each of the nodes are evenly kind of taking care of all of the different services. And in a multi-dimensional scaling, you have the ability to say, hey, node number 1 and node number 2 are taking care of the index and the query service individually. And then maybe the 3rd node is the data service. And as you scale up, you could just scale up data if you wanted to. You could just scale up the nodes that are involved with index or query or any configuration. Again, this is all kind of on the database administrator side, and it's not something you typically have to know as a developer, but it's great to know when you're getting into a database like Couchbase that these options are available for you. Another thing is flexibility. So we have flexibility in terms of schema. Now, in a relational database, you have predefined schema Your data needs to fit into predetermined tables, columns, rows, and then you need to use exact data types. So in Couchbase and other document databases, every write to the database could potentially be a document of a different size and shape, right? As long as it conforms to JSON, it gets stored with a unique key. So you can design your data based on your application and let your application determine the way that your model and your data is stored. And in a relational database, you need to follow specific rules and normalization. This can break up your data and create a lot of work to adhere to a specific schema on either write or read. Again, with a document database, there is no schema on write, but you totally have the ability to return data in a certain shape. And you can do that with NoSQL, our query language, to help you to join different documents together and then present them in a certain view. Availability. So high availability with Couchbase is achieved by means of cross data center replication, known as XDCR. Now, the contents of a bucket can easily be selectively replicated to a bucket maintained on a remote cluster, and server group awareness allows groups of nodes to be defined within the cluster, specifically to protect the cluster against failure. So again, great things to know as a developer, not things you necessarily have to be aware of at first, but from an administrative point of side, these are great things to understand about how these types of databases can scale up and scale down. The NoSQL landscape. So as you can see here, there are many types of NoSQL databases. Relational databases are great for answering known questions and are, again, like rigid in design. NoSQL databases can help you to answer questions that you didn't really expect and allow for a more flexible schema. The line between key value and document databases is often blurry at times, and most document databases fit into both categories. You also have graph databases that allow you to traverse and shy away from direct relationships. And you can think about this in terms of maybe like a Facebook group or all of your friends on Facebook, right? And how they create like a network of people that are related to each other. That's kind of one of the things that a graph database will allow you to do. And a wide column database uses tables, rows, and columns, but unlike a relational database, the names and the format of the columns can vary from row to row. So think about in a document database, how not every document has to be the same shape, right? If you have two different products, they may have different attributes in them. So a wide column data store is kind of similar to a relational database in the fact that it has tables and rows and columns, but they do not necessarily have to be the same, and you don't have to conform to a rigid schema every time that you insert. So with that, what I would say is that Couchbase falls under the kind of key value and document area, and there's many different databases that fall under this category. In fact, some span more than just the key value and document categories. We won't really get into that, but it is really hard to take a certain database and put it in one category of the NoSQL landscape, right? One database can potentially do many different things. As well, the NoSQL name is not the greatest name, especially for databases like Couchbase, which we use a SQL-like query language to query it with, right? It's not really NoSQL. It's document database with all the great things from the query language that you had in your relational database. So in a key value data store like Couchbase, you basically have a unique key for each document that's stored in the database. And with that key, you can get, set, replace, and delete, and also do things like MapReduce. So in MapReduce, the normal CRUD methods, the normal CRUD methods allow you to look up a document by ID, right? But in MapReduce, or what we also call a view query, it allows you to look up one or more documents based on various criteria. So MapReduce views are just like a map function executed once per document, and an optional reduce function can aggregate on the results of the map function. And the map and reduce functions are stored on the server and written in JavaScript. This is another reason why I really love Couchbase as the NodeJS developer advocate and someone who's really focused on JavaScript. I love the fact that you can store these things in Couchbase with JavaScript, that all of our documents are of a JSON type. And when I retrieve data from my database and use it in my application, I don't have to do a lot of work to be able to represent that data on the client side, which is just great. Now we do also have many different SDKs at Couchbase, so it's not just about JavaScript and Node. Obviously, we have Java, .NET, PHP, Python, all those great things. Now, why would you use a NoSQL database, or in particular something like Couchbase? Some of the use cases are caching, storing user profile information. In fact, that's a really big one. A lot of our clients do exactly that. Think of like LinkedIn and how they store their user profile. Other big companies, which I won't name, but are some of the biggest in the industry, use Couchbase. Content management, gaming, travel booking. So think of Amadeus and United Airlines, and also things like fraud monitoring. And we are big advocates at Couchbase of using the right tool for the right job. You can use Couchbase in many different ways. You can use it as a caching layer. You can use it as a document database, key value store, but we like to be able to inform our clients and the people thinking about using Couchbase as to where Couchbase shines, and also understand that you can use Couchbase in conjunction with other databases as well. You can ease into Couchbase very easily by just starting with caching first, and then eventually getting into document storage and stuff like that. So we'll talk a little bit about relational versus document schema. One of the biggest misconceptions about a document database is that just because there is no formal schema, it doesn't necessarily mean that a document database doesn't have structure, right? We do have structure, and we'll get into kind of how you go about creating that structure here in a few minutes. We have schema on read versus write. That means, like we said earlier, any document can be stored as long as it conforms to JSON. There is no necessarily schema on write. And then schema on read is actually more critical, and we do support that with our NoSQL query language. So understanding the trade-offs versus relational versus NoSQL databases is very important. Like I was saying, you can use Couchbase as a cache for your relational database. If you want to, down the road, you could migrate on your own timeline. We don't claim that document databases are always the right tool for every job. So, make sure you do your own research, due diligence, understand the trade-offs of using both, and consult a DBA or us if you would, if you're not sure whether a Couchbase or a document database is the right tool for the job, right? We'll always be super honest with everybody. All right, so getting into kind of the meat of the talk and kind of what the title of this talk is around, which is JSON data modeling. First thing we need to understand is what are embedded documents. So if you can imagine this document on the right-hand side, that the whole thing is a document that gets stored in a document database. So the red part of this document, the curlies within the curlies, I like to say, is JSON. It's basically a new object. So an embedded document is a case where one of your name value pairs, one of its values is another object. So when you see the curlies within the curlies, you can ask yourself the question, to embed or not to embed. And that's the question that we're going to try to answer. When should I put the red part of this document here into the parent document or a single document? Or when should I take that and store it in its own document and refer to it by some type of an ID? Okay. Advantages to having embedded documents is that you have a single atomic key value operation. So that means if you whether you're reading, writing, updating, deleting a document, there's no other documents that you have to worry about updating as well, right? Everything's contained within one document. There are no joins or nests required. There is no transactions involved. So you just save, update, add to the database as you want to. If all the data is important to that document and for a majority of your needs, then embed it for sure. You should always kind of default to trying to embed that information. With a document database, you get to choose the level of normalization, and repeated data is not always a bad thing. So if you find that the information inside of embedded document might be repeated in other areas and you're worried about that, it's not necessarily a big deal. It's more an issue of whenever you read that document, are you using everything in that document? If you answer no to any one of those items, like if address, if you're not using that every time you read a hotel document, then you might want to store it in its own document. Some of the disadvantages of embedding a document is that the document can become very large. So imagine instead of addresses, maybe we had a reviews attribute in here, and its value was an array of all the reviews for that hotel. And let's say it's a very popular hotel and it gets thousands and thousands and hundreds of thousands of reviews over the years. That document could get quite large. You might want to put those reviews somewhere else, and I can show you how to do that here in a few minutes. One of the other disadvantages is that your embedded document could have multiple levels to that. So just like we have an embedded document here in the hotel document, what if that embedded document itself had, had something else inside of it that was embedded, and then something inside of it that was embedded, right? Once you get to 2 or 3 embedded documents, or nested documents, I should say, you should think about kind of refactoring and putting that into its own document. Some of the steadfast rules for embed versus reference. Again, like I said, always try to embed rather than reference if you can. Reference documents when it's too large for the parent document. We have a limit of 20 megabytes. If you ever see your documents starting to hit 15 megabytes, that's big. And that's bigger than most document databases will allow you to store. You need to think about what you're going to do with that data. Parent document queries rarely use the data, like we were talking about. Think of over the wire. When I go to fetch this data, am I passing more stuff over the wire than I really need? It's a good reason to put in its own document rather than embed. Related data in another document will require a NQL query. So when you put that data in its own document, you're most likely going to need some type of a NQL query to reference the other document and kind of read both of them at one time. And that can lead to overhead in your queries and maybe not be as performant. And like I said before, NQL is our query language in the case that you did want to do queries like that. And it is a variant of SQL. All of the knowledge that you have from the SQL world, as far as querying tables and stuff, most of it comes over and you're able to use here with NQL. I would say 90% of that SQL that you already know is directly applicable to using NQL. And I just made that term, that 90% up, but I would say, yeah, a majority of what you know, you'll be able to carry over. When it comes to document relationships, nothing new here. If you've worked with relational databases before, you have a pretty good concept of one-to-many, one-to-one, one-to-many, and many-to-many, okay? So we're gonna talk about each of those and how you would model a document in each of these types of scenarios. So let's go ahead and get started with that. We'll first talk about one-to-one relationships. And the most simple one-to-one relationship in a document is your basic name value pair. Like for instance, even name here, right? A name is the actual key of this attribute. Sheraton Agora Hills Hotel is the value, right? So for name, you have a specific value that is a one-to-one relationship. Also, the embedded document that we kind of showed before, where you have address, and there's an embedded document in there. Even though this document is embedded within this JSON document, it's still considered a one-to-one relationship. Then you have the related document, which now we have 2 documents here, right? So just as before, we have a hotel document. In this case, the key for this hotel is Hotel 1000. And that is again, the Sheraton Agora Hills Hotel. But notice for address, here we have a number. Now that number is not the address of the hotel that you can find with Google Maps, but it is a number and an address that you can use to find that address in the database. So it points to another document. As you look down below, you'll see that we have another document with a key of the same number. And both with key value operations and NQL queries, you can kind of query related documents pretty easily. I'm not going to say that every time that you store a document like this and use NQL to query it, that you're going to have a key value operation going on behind the hood, but in most cases, that's what's going to happen. So it'll still be pretty efficient, even if you break up your documents like this. Still, a one-to-one relationship right here. This hotel has one address, and that address is only associated with one hotel, hence one-to-one. This is just a little bit more of an illustration of kind of how to think about this one-to-one relationship for the multiple documents, right? The address kind of just points over to another key in the database. The NoSQL query. So NoSQL, again, is our Couchbase query language. It's a SQL variant. And how close is it to SQL? Well, let's take a look at on the right here. If you've ever used SQL before, I think the only thing here that might be foreign to you is our on keys. On keys just kind of tells the NoSQL query that our hotel address, we are going to be retrieving on the key for the document. That's the simplest way to put it. But everything else here should look very familiar, right? We got select, from, join, where, and not under the hood, but when you're building a NoSQL query, you can use ANSI SQL, which is a standard form of SQL. And that way you can kind of ensure that the NoSQL queries that you're writing kind of conform to real SQL. Now, considering our related documents, this query will return both of those documents and kind of present them as one. We'll take a more look at that. So here is the resulting document that you would get back from this NoSQL query. And like I said before, even though the red part of this document is a separate document, when we retrieve it with a NoSQL query, the result back to the person calling for this document is a full hotel document. It looks like you just queried one document and you got that entire document back. So the next relationship we'll talk about is a one-to-few relationship. And this is kind of more of something that just the way that I think of one-to-few in my head. But when we have a hotel document and we potentially have multiple addresses, right? In fact, this is still kind of a one-to-one relationship here, right? The hotel document has addresses, and the value for that is, again, just a key that points to another document. However, in that document, we have multiple documents within it. So we have a one kind of to few, kind of a one-to-one, and then within that one document that we reference, we have few documents, right? So you can do things like this. If you need to store a main and a shipping address and other types of addresses for a specific document, you could do something like this. And it's very easy to retrieve this. As we already saw in the previous example with a NoSQL, you would do a very, very similar NoSQL example. This is actually what that NoSQL example would look like. And basically what we're saying when we say on keys is to look at the addresses field for the key and to go find the document that shares the same key. So select hotel, basically all the items from hotel, and addresses. We're going to select from the hotel. We're going to join on addresses, on keys, where the hotel.addresses value matches the addresses that we're referring. And then we also want to just say, we only want the documents where hotel type equals hotel. That just narrows down the documents we have to look at, and where the ID is hotel 1000, right? And that'll get our specific hotel, Sheraton Agora Hills, with all of its addresses. Next is our one-to-many relationships. So in the case of an embedded object, here we have a list of reviews. And this is what we kind of talked about before. Let's say that a hotel has many different reviews. Well, you could store them all in the document under reviews as an array of objects. So this is kind of the most simple example of a one-to-many relationship, all contained within the same document. And in order to get this document, since we don't have the reviews in their own document, which basically has a value of an array of reviews, or maybe we could also do like 3 different documents that we refer to. But in this case, like I said, we have it all inside of this hotel document. We haven't broken up the data. So we can do a very simple collection.get The code that you see on the left-hand side is an example from the NodeJS SDK, and it's super easy to get. You just call collection.get, you pass it the ID, or sorry, the key of the document that you're trying to retrieve, and it returns the entire thing. It's that simple. Here are some of the other CRUD operations, just for reference. If you were using Node.js SDK, notice that the get and the remove, all they need is the key to the document that you're trying to either get or remove. Whereas the insert, update, or replace, they all need, if you're inserting a document, it's going to need a key, and it's going to need a document to be associated with it. If you're going to upsert, that means you're going to either insert or update, depending on if the document is already there or not. You're still going to need a key and a document. And replace, obviously, we're going to take a document that's already in the database, we're going to reference it by key and pass a new document to replace it. So next in our one-to-many relationships is a related document. So as I was saying before, instead of storing all of these different reviews inside of the hotel documents, what we can do is every value in that array could be another document in our Couchbase database. So in this case, we have the Hotel Kabuki, which is located in San Francisco. And each of the reviews, every time we add a review, we generate a new document on the database called review underscore whatever the ID is for that review. And then we would also come and update this document and put a new entry into this array just to associate them together. This is what those reviews might look like. I just put a slide on here to kind of show you, what would these individual reviews look like? And then also a little bit better of an illustration of kind of how this relationship is represented in our database. Right on the left, we have our document with a reviews array, and each of the individual reviews are basically a key of a document located somewhere else in the document, in the database. And we can do a NoSQL query to retrieve all of them. And the NoSQL query would look just like this. So what are we doing here? We are, again, selecting the hotel and reviews, right? From both the hotel and reviews. So when we say hotel and reviews, we're thinking of all the documents that either have a type of hotel or review, or maybe in Couchbase 7, which will be out soon, are part of a collection of hotel or reviews. And we are going to basically nest our reviews, and it says on meta reviews ID. Now that's just a fancy way of saying by the document's key, by the review document's key, and then and where those items are going to be located are in the hotel.reviews. So as you can see here on the right-hand side, our document has a reviews, and then in there we have a bunch of different items, and each of them have a key to another document in the database. That's what in hotel reviews means. Like, where do I find these reviews? Well, they're inside this document and they're under reviews. And then of course, narrow down the documents we have to look through by saying hotel type equals hotel, and where the ID is the hotel that we're looking for. All right, many-to-many relationships. The bound version. So an airport can have many airlines operating, and similarly, an airline can operate at many airports, right? So as you see in our documents on the right-hand side here, we have two different documents. One is an airport, San Francisco International, which is one of the closest airports to me. And the airlines, same kind of thing that we did with the reviews earlier, right? For airlines, we have 3 different airlines that operate at San Francisco International. So this is obviously made up and contrived data, but let's just say that San Francisco only had 3 airlines operating at it. This is how you would represent that document in the database. And each of these airline 3000, airline 4000, airline 5000, these would be, like United Airlines, Delta Airlines, whatever. And then on the airline side, right? So let's go take a look at one of those airline documents. And that's the one on the bottom here, airline 3000, United, right? And then we could refer back and say, this airline operates at airport 1000 and airport 2000. So we know which one airport 1000 is. That's at San Francisco International. And then, airport 2000 might be Los Angeles, LAX or something. So this is bound because on both sides of the relationship, each document has a reference over to the either airlines or airports that are associated with this document. Now, this is not my favorite way of doing it, but I want to show it because it's a valid way of representing this many-to-many relationship. Now, the NCL query gets a little bit more involved here, but the great thing about using NCL and SQL is that once you kind of understand the basics, for instance, all the information that we already went over on the other NCL statements, everything applies here for the most part. There is one new concept here, array airport name for airport and airports. Just think of that as kind of like a for loop almost. So as you can see here, we have an airline 3000 and all the airports that are returned from that. This is basically what you would get back with this NCL query. And I won't go in detail about how this NCL query works. However, at the end of this talk, I do have a link where you can go and take a look at a code base where I have built it with NodeJS, and I have all of these documents added to the database, and then you can query them, and you can see exactly how each of these queries work, and then other kind of similar versions of the same query done in different ways. So it's a good resource if you really like all the slides and want to learn more about NCL. It's a great little project to pull down that works with our sample data set called travel sample. If you'll notice that all of the stuff that we're working with now are travel related documents. So it's very easy to get started with because the data set's already provided for you. Same thing with airport. So the NCL query here that we first went to, this is for airline. And then to turn around and get the airports associated with airlines, then you're pretty much just using the same NCL query, but everywhere you have airline and airport, you're kind of just swapping those terms, right? So it's a very similar NCL query. And again, this will either return all the airports with the airlines that operate at it, or all the airlines in each of the airports they operate at. So that was bound, right? Where we're keeping references to the related documents inside of the document. Now here we have unbound, and again, an airport can have many airlines operating, and similarly, an airline can operate at many airports. But let's say that we never really had a reason for keeping track of the different airports and airlines in our database until now, right? And one thing that we don't necessarily want to go do, and this may not be the only reason that you want to choose the Unbound version, but it's just an idea that I came up with, right? So let's say that you didn't want to affect any of the current airports or airline documents in the database. You wanted to keep track of those relationships somewhere else. Well, in that case, your documents wouldn't change at all. Notice here, we do not have any type of a reference on airport of what airlines operate at it, and we don't have any reference on the airline document of what airports it operates at. So how then do you keep track of these relationships? Well, just like you would in a relational database with an associative table, you can keep track of these relationships with associative documents. So here, so taking these two documents that we already had, right? And then also these extra documents here, which are of a new type, right? These are not of type airline. These are not of type airport. These are of type airline underscore airport. In an associative document, think of it as kind of like a bridge document, and think of that underscore as a bridge, a link between the two, airline and airport. How are they connected? Well, here in our first document, we have airline airport underscore 100. So this is kind of like the first document that we've created to represent one of these relationships. And it takes airport 1000 and airline 3000 and kind of relates them together. So where we saw before, where we had, all the airlines in an array and then all the airports in for United. So here, San Francisco and United relationships are all represented here in two documents. Well, instead of that, we could leave those two documents alone And then we could add these 5 documents, which just track those relationships between the two. So then all you need to do is add those related documents, those associative documents, and then you can query them like this. So here we say select airport name. So in this case, we just want to get the airport name back, but we also want to include an array of all the airlines for that airport. So we use the array aggregate and airline name as airlines. And so we're again selecting from airport, and we're joining on AA. So AA is the airline airports kind of document type. And you'll see that down here at the bottom. And we want to join on basically the airport's ID, where it matches the airline airport's associative documents airport ID. And then same thing, we're going to join travel as airline. I'm sorry, join in our travel bucket as airline on the airline's ID, where it matches the associative documents airline ID. Right? I know this is a little bit complicated, but it all makes sense. And it's not really a long query to write to be able to basically retrieve all this information, because in reality, the documents that we're receiving back here are not stored in the document in the database in this manner, right? They are stored all as different documents. We got the airlines over here, the airports as other documents, and then we have these associative documents. But with this nickel query, we can kind of shape together all those documents and return them in a fashion exactly how the API or the user wants them to be returned. So schema on read, right? You can define any schema or shape that you want from the documents in your database. If you can think up the nickel query, you can represent the data like that, which is very, very powerful. And it's also, again, once you get the hang of nickel, it's super easy to bang out one of these queries and again, represent your data however you need to. So again, here we are grouping. Let me just sum this nickel query up real quick. We are grouping our airlines in an array as airlines. We are joining on those airport and airline IDs by type of document from the associative documents. So I hope that makes a little bit more sense. Now, this is the first nickel query that we've done so far that I've showed you that actually needs some type of an index. So just like in a relational database, once you start doing advanced queries, you will need some type of an index to be able to make sure that you can get the data from the database in a performant manner. This is what we would call a secondary index. And in fact, it's a composite secondary index because it actually is indexing on different attributes of the document. So it is taking into consideration type, airport ID, and airline ID. Yeah, and it's a very simple index. It's not a whole lot of work to write a simple index like that for your query. And it'll make sure that that thing returns back in a very performant way. I won't go too far into indexes, but in the slide that I'm going to show at the end, we do have lots of different resources on everything from JSON data modeling to how to build indexes and some of the other projects that I put together that you can pick up and download off of GitHub and run yourself against our database. And here are the resources for the talk. So basically tinyurl.com/json-data-model. And we can actually go ahead and pull this up real quick. So here we go. This is the repo with all of the different examples of all the nickel queries and even setting up all of the documents for our database. So if we go into here, we'll see that we have a one-to-one, one-to-many, and a many-to-many folder. And in each of those, you will find how to upsert the different hotels, how to query those hotels, how to upsert the addresses by themselves. And you could use this in conjunction with the slides, walk through the slides and kind of walk through each of these folders just to get a better understanding of how to use the Node.js SDK to not only insert those documents, but also how to read them. And then if you also look here at this all nickel examples.sql file, it's not actually SQL, but I had to name it SQL so that it would show up properly here on GitHub. Here are all of the different queries that we referenced in our talk. And I double checked and made sure that each of them work. In fact, that's the reason why we have this repo here, is because I didn't want to provide any slides with nickel examples on them that didn't actually work. So this is a great resource. And as well, you will find other links here, like I said, on all sorts of topics that are involved with JSON data modeling, retrieving documents, how to build nickel queries, indexes, all that kind of stuff. So with that, I'm going to wrap up the talk. Again, my name is Eric Bichard. You can reach me either at my email here or at HTTP Junkie on Twitter. My DMs are always open. If you have any questions, any issues with the repo, or just want to hit me up and say hello, go ahead and do that. You can also find our website, couchbase.com, and Couchbase on Twitter and Facebook if you want to look us up. And with that, thank you for joining today and have a great day.